Today in pre-cal we learned about composite and combinations of functions. The first side of your notes is sum, difference, product, and quotient. To find the sum of f plus g of x, you're going to do f of x plus g of x. Basically, you're just adding the two functions together. If you want to find the difference, you're subtracting the two functions. So f minus g of x is like doing f of x minus g of x. You're subtracting the whole function, so here you'll want to be sure you use parentheses. You'll see what I mean on that in a second. For product, you're multiplying the two functions, so that's f of x times g of x. And for division, you're going to do f of x divide g of x. Right here, you need to be sure that g of x does not equal 0, because if it does, it's going to be undefined, and an undefined function is not a function at all, so that won't work. Okay, let's look at some examples. The first example, we're going to use f of x equal to 2x plus 1, and g of x equal to x squared plus 2x minus 1. We want to find f plus g of x. So we're going to start by rewriting it as f of x plus g of x. And then we're going to replace the functions with what they are. So f of x is 2x plus 1. I got that from right here. I'm just replacing. Then g of x is x squared plus 2x minus 1. So I'm adding that, so I put the plus sign in between. And then x squared plus 2x minus 1. I have now added those functions together, and all that's left to do is to simplify. The 1 and the negative 1 cancel, and then I write it in standard form with the highest power first. So I have x squared, and then 2x and 2x makes 4x. And x squared plus 4x is my final answer. On example 2, we're looking at one that's subtraction. We're still using the same f and g of x. So we're going to write it as f of x minus g of x. And then we'll replace f of x with 2x plus 1, because that's what f of x equals, minus, and then right here's where you need to use parentheses. The reason that's a big deal is if you don't, you're not going to have the right signs. So now I'm replacing this with x squared plus 2x minus 1, because that's what g of x is. I'm subtracting the whole function, so I put it in parentheses. And then I need to distribute my negative. So I'm going to copy my 2x plus 1, and then distribute negative x squared, negative 2x, and positive 1. When I do that, I've looked for anything that will cancel. 2x and negative 2x cancels. And I've got negative x squared plus 2. Again, just combining my like terms. The next question says, what if I'm doing f minus g of 2? You'll notice the only difference here is that I'm replacing x with 2. So now I'm going to look back at this function and put 2 where I see x. So I'm going to do negative, in place of x, 2 squared plus 2. 2 squared is 4, and then reattach the negative, plus 2 is negative 2. Now in your homework, you're going to have some where it's going to go straight to here and you won't have just done that function. If that happens, you are going to plug in 2 to the f function, like up here. 2 times 2 is 4, plus 1 is 5, and then you're going to plug in 2 here. 2 squared is 4, plus 2 times 4 is 8, so 8 plus 4 is 12, minus 1 is 11. 5 minus 11, oh no, something went wrong. Okay, let's write that out, because that should have worked out. Okay, 2 times 2 plus 1, and then the second one is 2 squared plus 2 times 2 minus 1. Oh, I plugged in the wrong thing on the second one. Okay, 2 times 2 is 4, plus 1 is 5. 2 squared is 4, plus 2 times 2 is another 4. 4 and 4 is 8, minus 1 is 7. And then if I do 5 minus 7, I get negative 2. So that checks out. And that's how you subtract if you're not given an x. The third example on this side is to do f divide g of x. So you're going to do f of x divided by g of x. When you do that, you're plugging in your function. So you've got the square root of x over the square root of 4 minus x squared. There's not anything you can do to simplify there, so that is your final answer. And that's usually going to happen on your f divide g of x. It's just going to stay the same. There's nothing that can be reduced. On the flip side of your notes, we're talking about combinations, or compositions, excuse me. The composition of f with g is f of g of x. It can be rewritten as f of g of x, where x is nested within g and g of x is nested within f. You'll notice that this looks like the word fog. That sign in the middle is composed with, f composed with g, or f of g. So look out for that. That is not the same as multiplication. So if you just multiply the two functions, you're not going to get the correct answer. Let's look at some examples. First, we want to find f of g of x. When I do this, I think of this as doing two separate processes. I'm going to do the g of x function and then plug that into the f of x function to get my answer. So I'm going to rewrite it, f of g of x. I'm going to replace g of x with what g of x is. In this case, it's 4 minus x squared. Again, I just replaced the whole g of x with what g of x equals. Now, I'm going to go to the f function because this tells me f, so I'm going to go look here. Where I normally see x, see how this is f of x and this is f of x, except this doesn't say x anymore, it says 4 minus x squared. I'm going to replace the x with 4 minus x squared, and then continue on and write the plus 2. Again, I'm just replacing this stuff where I used to see x in the function f of x. Now that I've done that, I can combine my like terms, and I've got negative x squared plus 6, and that's my final answer. It's important that you understand that two things are equal and they're being replaced to compose a function with another. The next thing it asks us to do is find g of f of x. So g composed with f of x is g of f of x. We're using the same functions we were before, but now we're starting by replacing f of x with what f of x is, and that's x plus 2. So I replace it with what it equals. Then I'm going to go to my g function, and I'm going to write 4 minus, and where I used to see x, now I should plug in x plus 2, and then back up here squared. To simplify this one, I need to FOIL x plus 2. Do that one twice. So I've got 4 minus x squared plus 2x plus 2x plus 4. When I distribute that negative, I have 4 minus x squared minus 2x minus 2x minus 4. Cancel my like terms that cancel and combine the ones that don't to get negative x squared minus 4x. Hopefully you're seeing that these two are not the same, even though this is f composed with g and g composed with f. Many times these two things will not be the same. If they are, it's an inverse, which we'll talk about more later next week. The last thing on this example is to find g of f of negative 2. Just like we did on the other side, we've already found g of f of x right here. So now we can just plug in the negative 2. When we do that, we have negative 2 squared minus 4 times negative 2. Be sure you watch your order of operations there, because if you don't, you're going to get an incorrect sign right here. Negative 2 squared is positive 4, and then reattach the negative, so that's negative 4. And then negative 4 times negative 2 is positive 8. And negative 4 plus 8 is 4. And that's it for example 3. For example 5, we're going to do just one more composition. This time my f of x and g of x are changing. I want to find g composed with f of x. I can go ahead and rewrite that. G of f of x. I can replace f of x with what f of x equals. So g of x squared minus 9, because that's what f of x is. Now I'm going to go to my g function, and where I used to see x, replace it with the new x. So I have x squared minus 9, and then plus 3, because that replaced just my x value. Now I've got x squared minus 9 plus 3, and I can simplify that by adding negative 9 and positive 3, and I get x squared minus 6. And that's my final answer. The assignment for this is assignment 10, and it's page 89, numbers 5 and 6, and you're doing all parts, 13 and 14 all parts, and 31 to 34 parts A and B only. Good luck, and let me know if you have questions.